All right, ladies and gentlemen, here we are again with another exciting math lesson, continuing in Module 2, actually really continuing what we were doing last time in Lesson 13. So for today's Module 2 notes, we are moving on to 2-14, but it's going to be pretty similar to what we did, again, in the last lesson. Today we are going to do more converting. We do more converting with decimals. And actually, let's make sure I include that properly. More converting measurements. More converting measurements. Important to know what specifically we're going to be changing back and forth. Now in the last lesson, most of the converting that we were doing was going from big to small, so we had to multiply. This time we're going to do a little bit more with division, but again the process is going to be very, very similar. So 10, 15, 1 less than 15. So xiv, 10 plus 1 less than 5. When you get into these bigger numbers, you start to see why we don't really use Roman numerals anymore. They're a little complicated sometimes. So xiv for 2, well, for 14, not the 2. All right, more converting measurements with decimals. We are going to begin with the same basic principles as last time. Okay. Basic principles or big ideas. And for this, I'm going to say C 1-4 and 2-13. Okay. If you need to review any of this, you might want to go back to those two lessons. Now, I've said it once today, we said it in the last lesson. If you're going from a larger unit, big, to something small, then you are going to multiply. A larger unit, like a foot, is made up of many smaller units, like inches. So every 1 foot you have is equal to 12 inches. 2 feet would be 2 groups of 12, so 24. Now, as I already mentioned, for this lesson, we're mostly going to be going the other way. We're going to start with the small units, and we are going to use them to convert to the big units. Basically, we are going to take the smaller ones and we are going to group them into chunks of a certain size. And anytime you're taking a large collection of something and splitting it up into smaller, equal size pieces, you're dividing. Okay. So, for letter B, our procedure, strategy. Again, this is going to be very similar to yesterday. Very similar to the last lesson, I should say. We didn't watch it yesterday, most of us. The last lesson, I gave you an example. Jesse had 53.5 feet of wire. Okay. For this one, let's say, actually, you know what? I'm going to simplify a little bit. I'm just going to write convert 5,317 centimeters to meters. Now, you can do this the same way we did the other ones. 5,317 centimeters is equal to, I don't know how many, meters. I know that 100 centimeters is equal to 1 meter. And then I'm going to use an arrow to help reinforce that I'm going from centimeters to meters. Now, if I had written this the other way with the meters on this side and the centimeters on this side, the arrow would be going the other direction. Because ultimately the arrow should always be moving toward wherever the unknown is. It needs to move towards what I need to find. That might be on the right, it might be on the left. I don't know. But when I write my equivalence, when I write my relationship up top, the units should line up. So centimeters with centimeters in this case, meters with meters in this case. Messed up my arrow. Okay. To go from 100 centimeters down to 1 meter, I am going from having a lot of centimeters to putting them together in just one single group. So a lot of little pieces to one single big piece. I am dividing my 100 centimeters into groups. 100 divided by what equals 1? Itself. Okay. 100 divided by 100 is 1. So for this, I am going to look at 5,317, and I am also going to divide that by 100. Now I can do the long division. Draw my division hut. Here's my dividend, 5,317 divided by 100. And I'm going to go ahead and do this. But I'll be honest, this is not my favorite. It takes a while. 100 into 5 doesn't work. 100 into 53 doesn't work. 100 into 531 works 5 times. 31. Bring down the 7. 100 will go into 317 3 times. 3 times 100 is 300. Subtract, subtract. Now I have to add a decimal and a 0. 100 will go into 170 1 time. Now I'm hoping that by now you're noticing a little bit of a pattern. If not, don't worry, I'll talk about it in a moment, but 1 times 100 is 100. I'm guessing a lot of you see it. Oy, another 0. Bring it down. 100 goes into 700 7 times. 7 times 100 is 700. My goodness, finally, I am done. 5,317 divided by 100 is 53 17/100. Is there an easier way to do this? I'm glad you asked. Down here, I'll skip a couple lines. Okay. 5,317 divided by 100. If I take those exact same digits, 5, 3, 1, 7, because I am dividing by a power of 10, because I'm dividing by 100, 10 times 10, I can put my pencil right here where the decimal would be, and I can take my paper and say, well, if I'm dividing, all of these digits are about to move to the right. If I'm dividing by 100, they will move to the right 1, 2 spaces, 2 spaces. So everything's moving over 1, 2 spaces. That invisible decimal point ends up becoming visible right there. A lot of people look at this as the decimal bouncing over 2 places. That's kind of what's happening. But more accurately, as I am dividing by 100, all of these digits are shifting down 2 places into lower place values. 5,000 becomes 5 tens. Okay. 300 becomes 3 ones, and so on. Same answer. You pick the method that works for you. Now the book will suggest something else. The book will suggest something else that I don't necessarily love, but since this is very familiar, we'll take a moment and we'll discuss your other option. Or if you don't like the way that I showed it earlier, you can try it this way. You can try it this way, but be careful. Again, I don't think this is quite as straightforward, but I will show you, and then you can decide what you like. All right, exact same numbers. Convert 5,317 centimeters to meters. Now, what we're going to do is take 5,317 times, now I'm going to use parentheses to show that this is one value. It's going to be in a couple parts, but it's one value. This is 5,317 centimeters, so I'm going to write 1 centimeter. Okay? Hopefully that makes sense. 5,317 centimeters, 5,317 1 centimeters. Okay. And this is where it gets weird. For the next line, 5,317, that's the same, times. Now I am going to have the same value, but I am going to make it look different. I know that 1 centimeter is the same as 1/100th of a meter. There are 100 centimeters in a single meter. So 1 out of 100, 1/100th of a meter is a centimeter. I will multiply these two together, which really is just going to be 1 times this, 5,317, except, shouldn't put that yet, because the 1 times, that makes sense. You know what, let me go ahead and show you. I wasn't going to do it this way originally, but I changed my mind. Okay. That's very badly lined up. I wish I had graph paper. 1 times 7, 1 times 1, 1 times 3, 1 times 5. I could do the 0 times 0 times 0 times, but it's just going to be all zeros. It's not going to change anything. It's not going to adjust the number. Once I've multiplied, I count the decimal places. 1, 2, 1, 2. I bounce it over. One spot that way. 53 and 17/100ths. It's the same as what we had up here. 53 and 17/100ths meters. Essentially, if I have this many centimeters, 5,317, that means I have 53 total meters. Think about your meter strip. As someone pointed out, there's one in your Learn book right before lesson 13. Think about your meter strip. If I have 5,317 centimeters, it's like 53 of those meter strips. And then 17/100ths, basically 17 centimeters left over. Now, I said before, I will say again now, I will say again in class, I don't particularly like that method. I like how it uses algebraic thinking. We're taking one value and exchanging it for an equal value that just looks different. It's the same amount of stuff. But I think it requires you to know not only that 100 centimeters make a meter, but then I can write it this way as a decimal, and I don't feel like we're quite there. So I wanted to show you, feel like you got a little something new today. We will come back to this kind of thinking throughout the year, but for right now, for your test, don't stress over this too much. Most of us, I think, are going to be using this process. Okay. I will say, though, a lot more division over here, especially when we use customary units. Anyway, I will let you decide which ones you feel are most comfortable for you. We will do more examples together in class tomorrow. We'll do more examples in class tomorrow. For now, just make sure you have this copied and enjoy the rest of your afternoon, evening, morning, whenever you happen to be watching this. Thanks, folks. I will see you in class.